Hi everyone. So today we'll be doing exercise 2.3 of the chapter Polynomials in class 9 Mathematics NCERT. So let's start with question number 1. The question says, find the remainder when the polynomial x cube plus 3x square plus 3x plus 1 is divided by the following. The first part is x plus 1. Now this is just a simple application of the remainder theorem that we studied in this chapter, and I'll just recap what the remainder theorem is. According to the remainder theorem, any polynomial p of x when divided by the divisor x minus a will give me the remainder equal to that value of the polynomial at which the divisor is equal to 0. Which means here if I make x minus a is equal to 0, giving me x equal to a, replacing this value in the polynomial will give me the remainder. So out here, taking the 0 of the polynomial in the divisor, I get x plus 1 is equal to 0 or x is equal to minus 1. When I take p is equal to minus 1, it will give me the remainder, which is minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. This gives me minus 1 plus 3 minus 3 plus 1, and the remainder is 0. Now for my second part as well, it's the same polynomial in question, which is x cube plus 3x square plus 3x plus 1. The second part is asking us to find the remainder when we divide the polynomial with x minus 1 by 2. Now taking the 0 of the polynomial, which is the divisor, we get x is equal to 1 by 2. And hence the remainder when we divide the polynomial by x minus 1 by 2 will be the value of the polynomial at 1 by 2, which is 1 by 2 whole cube plus 3 into 1 by 2 square plus 3 into 1 by 2 plus 1. This gives us 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. Take L as a common LCM base. I get 1 plus 3 2s are 6 plus 4 3s are 12 plus 1 8s are 8. This gives me 27 by 8 as the remainder. And third part is where the divisor is simply x, which means the 0 of the divisor is x equal to 0, and so the remainder will be p of 0, which is 0 cube plus 3 into 0 square plus 3 into 0 plus 1, which is equal to plus 1. And hence when I divide the given polynomial by x, the remainder I get is 1. Moving on to the fourth part. In the fourth part, the divisor is x plus pi. Now I'll equate x plus pi is equal to 0 to get the 0 of the divisor, which is minus pi. And according to the remainder theorem, the remainder when I divide the polynomial with x plus pi will be that value of the polynomial at minus pi. This gives me minus pi whole cube plus 3 into pi square plus 3 into pi plus 1, which gives minus pi cube plus 3 pi square plus 3 pi plus 1. The fifth part of this question is the divisor equals to 5 plus 2x. Here, let me get the 0 of this polynomial by equating it to 0. This gives me 2x is equal to minus 5, or x is equal to minus 5 by 2. Now, according to the remainder theorem, in order to get the remainder, I will replace x with minus 5 by 2 in the polynomial, which gives me minus 5 by 2 whole cube plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1. This gives me minus 125 by 8. This gives me 75 by 4. Third term is 15 by 2 plus 1. Again, common denominator 8. I get minus 125 plus 150 minus 60 plus 8. This gives me minus 27 upon 8. So minus 27 upon 8 is the remainder when I divide this polynomial by this one. That brings us to the end of question number 1. Question number 2 of the exercise says find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Again, we can simply use remainder theorem. Here we'll equate the divisor equal to 0, which gives us x equal to a, and according to the remainder theorem, the dividend at value of x equals a will give us the remainder. So this gives me a cube minus a into a square plus 6 into a minus a. This gives me a cube minus a cube plus 6a minus a, which is equal to 5a. So remainder in this question is 5a. Now third question is asking us to check whether 7 plus 3x is a factor of the polynomial 3x cube plus 7x. Now, in order to know whether this is a factor of the polynomial, we can use the remainder theorem and check what the remainder is. If the remainder is 0, then we know that this is indeed a factor of the polynomial. If it's a non-zero, then it is not a factor. So in order to get the remainder theorem, I'll take the divisor 7 plus 3x and equate it to 0. This gives me x is equal to minus 7 by 3. And in order to get the remainder, I will equate minus 7 by 3 in my dividend. Gives me 3 into minus 7 by 3 whole cube plus 7 into minus 7 by 3. This gives me minus 3 into 343 by 27. This gives me minus 49 by 3. To be honest, I don't really need to solve this further. I know that these are two negative terms adding up, and this will never give me a zero solution. It will always be a non-zero solution. And since it's a non-zero solution, we can say for sure that 7 plus 3x is not a factor of 3x cubed plus 7x. And that brings us to the end of exercise 2.3. I have not gone ahead and done the proof of the remainder theorem. In case you feel that you want to learn the proof or you want me to explain the proof, I can do a separate video on that. Let me know in the comments. Thank you for watching this, and please leave a comment for any questions or reach out to the email ID in the description. I'll see you in the next video. Thank you.